उस पर कर देना जिसके ऊपर लिखा है ना जो टेस्ट होती है बड़ी चीज़ होती है ट्रांसफार्मर जो है मीडियम वोल्टेज बड़े पैकेज आता को
take measurements and generate high voltages for the AC, DC or impulse testing. Now this impulse test, the particular impulse test which we are discussing today, is used as a type test at various voltages, and this particular setup is suitable for 11 kV equipment, including the outgoing, incoming panels, CTs, PTs, cables, etc. Distributor transformers, of course. And the requirement of the clients all over the world is that when they buy a batch of equipment, 11 kV equipment, then they need an independent agency to perform a type test on one piece of that particular lot, and if it passes that test, then that lot is purchased. So apart from the fact that this lab could be used for research purposes, this is also being used to conduct impulse tests. So let me explain how the system works. The approach here is modular. Right now the setup is a single stage setup. It could go to double stage or even triple stage, and you can see here, and this area we are looking at, this area is the testing area. Here the today's address of it is a potential transformer, which we call NED. And the heavy equipment you can see would be brought from this larger gate from outside trucks, and the equipment is placed here. Now while the test is performed, if somebody opens this gate, then there is a safety arrangement that the control desk will automatically shut this off. And for that matter of fact, there is this rod is the earthing rod, and before touching any element one has to keep this rod on it. And the earthing switch, of course, that this earthing switch, this position shows that the system is grounded, and this is controlled from the control desk. Now let me explain to you. Now this transformer is going to up to 100 kilovolts. That means the peak value will raise up to something like 140 kilovolts. Now this voltage is controlled through another small transformer inside the control desk, in the control room, which you can see through the glass window, from where we can vary this voltage. Transformer is rectified through the rectifier. You can see the symbol here. This is the rectifier, and the rating here, of course, is written 140 kV and 20 milliamps. Then you can see that there is another piece. Give me some room. And you can see from there only. Then there is another rectifier. Then we have the measuring resistor. This element, vertical element, is the measuring resistor, so that it can measure whatever DC voltage appears at this point. And this green color is the conductor, the aluminum conductor. And then we have, if you look here, 10,000 picofarad capacitor, which stores that DC energy up to the level where the voltage is charged up. So the charging voltage is retained inside this capacitor, measured through this measuring resistor, and then you could see that we have a trigger gap here. There are two balls. Now one of the ball contains electronic circuitry to generate high voltage, and you can see that the coupling is through the fiber optic cable. Again, for safety sake, there is a fiber optic cable. When I trigger from inside, then it generates around 15 kilovolt here, and a spark appears, so that the flashover is possible. Now once the spark appears here, then the insulation of the air inside these two is broken, and that energy, say if you are trying to measure, trying to perform test at 95 kilovolt, then this charging voltage, say it is 102 kilovolt, then that passes through here. An arc is formed which provides a low conductance. Another resistor which is in parallel going to ground is 6100 ohms. Now it is to shape the waveform, impulse wave shape, which I am going to explain, so that the rise time is around 1.2 microsecond to attain a value of 95 kilovolt. Then here we have the measuring capacitance, and in the measuring capacitance it's a high voltage divider, and then at this point this NTZ is there, which is a low voltage divider, as well as it connects it to 75 ohms impedance matched. Then the same voltage is going to appear at this point. Here you can see another gap. This is the measuring gap. Now the purpose of measuring gap is you can measure the voltages which are appearing here by adjusting its distance, and if and the adjustment is such that at 50%, half of the time, that is 50%, it triggers flashes. That means approximately that is the voltage which is appearing. So secondly, for the chopping waveform, there is another test where the chopping is required. There also it can be used. In that case, this lower sphere is again interchanged by means of the electronic triggering device. Now here we connect, and you can see that we have connected the phase where we have to apply the lightning impulse, and the secondary is shorted and grounded. Now this ground is connected here, and one of the important safety, you can see that all these rods, they are very low inductance, low resistance path for the ground. In addition to it, you find that there is strips, copper strips, flat strips, again to make the grounding very, very effective. And then there are two, this is also a ground wire for the larger equipment.